other numbers do you want to see if you go over? We got 3, 4, Alyssa. Let's see what these ones are. Okay, so I think I've seen at least one of every number, so let's do this. 1, 2, and 5 can all be done on Desmos, so we'll be doing those anyway, and then I saw 3 and 4, so we'll do those. And then after we go over this, you guys will be turning in your answer sheet. So when we come back, you'll get a new one. So, yes, you could do the first one algebraically, but I'm going to show you on Desmos. If I put in those two order pairs, and -1, they are going to fall on the same vertical line. So if I'm thinking vertical line, that's x equals, this is my $4, x equals has an undefined slope, so my slope would be undefined. If you were doing the math, you would have gotten zeros in your denominator. Remember, you cannot divide by 0, so that would be undefined. Questions on that? 2 can also be done in Desmos. And that one says g of -4, so that's your x value. So if I put -4 in for all of your x's, -4 squared minus 2. Use parentheses if you didn't, your answer is going to change. So should be 29.
Try again.
So g of -4 equals 29, or g of x equals 29, either or. Three is just asking about the range. The wording is weird, but that's how you may see it on the SOL. What are the ordinates of the following relation? It's just, what is the range of this? So look for your y values, list them least to greatest without repeats. So -2, 0, 1, 3. Four on the back goes kind of hand in hand with number 1, except it's talking about the equation. The equation is vertical, so it has to be an x equals. It's on -3, so x equals -3 is the line that's graphed. Those are things you have to know. And then 5 was meant to be a whole number. Like when you got the solution, I just realized that it was not that. But I'm going to show you what happens in Desmos, and then we'll graph that and try to graph the other one. So y equals -3x plus 5. 3x, not 35. Okay. And then -3x plus 4y equals 6. So in Desmos, or if you solve the second one algebraically for y, that would be your solution. So write that down, because that is the actual answer. But if you graphed it and tried to find the solution, you could have guessed like 0.2 and 4.5, or 0.5 and 4.5. You could have guessed. So I'll write down that answer and then we'll graph it. the first one starts at 5, has a slope of -3, so down 3, right one. You don't need this point up here, I'm just doing it similar a little bit more here. And so the other one I'm going to graph from Desmos. If you did it algebraically, that's fine. So 4, 31. I have a y-intercept of 4. It goes through, I think that's supposed to be 4, 7. Yeah, it did it. So 4, 7, and then I'll count the slope and do that. So my slope here would be 1, 2, 3, 1, 2, 4, 4, 3, 4, sorry. So go down 3, left 4, down 3. So when it crosses, it's somewhere in between instead of on the lines. So if you would have guessed like 0.5, 0.4, and 4.5, that would be fine. But because you have Desmos, you can find the exact answer, so I would want you to find the exact answer after you've made a guess. Questions on that one? Go ahead and pass your SharkBite answer sheet up to the next table. Okay, so we are going to go through the SOL review. I think we'll have time to do that before lunch, and then we'll start our actual lesson until we get back from lunch, but let's do this. So 4C was solving literal equations. This is something you would have had to work out because it's not something you can do on Desmos. So your first step for 18 would be getting rid of the 1/2, multiplying it on both sides. Multiplying 2 on both sides, sorry. And then we kind of talked about this when we did literal equations the first time because the concatenate was weird, but then you would have had to remember that for this. So after you multiply by 2, the 1/2 goes away, and then these both have an h, and that's what we are solving for. So I undistributed this, and we'll talk about that later. Took the h out of both of them, and then divided both sides by a minus b to see what was left. So h equals 2a all over a minus b. 19 was similar. You needed to solve for a. There was an a in both, so pull the a out of both. 3 plus 5c was left, and divide both sides by 3 plus 5c. Questions on either of those? Matthew, are you writing this down? 20 had 2 parts, but you used the same equation for both. So part A will solve for h. Get rid of the 2b by subtracting. Divide both sides by p. And then part B was basically the same, but switch. Solve for b. Get rid of the hp by subtracting, and then divide both sides by 2. Questions on any of those before we move on? Anyone still writing 18 or 19? All of 4D could have been done in Desmos, so if you put both of those in, make sure you're paying attention to the directions. 21 just asks you to find the x value, so x equals 7. When you put both the equations in for 22, you got no solution. If you put each of those in, it was asking which one does not have or is really no solution, and that was C. 24 and 25 are both asking for the x value, so x equals 6 and x equals negative 6. (26) gave you a graph and you had to find the x value, which was negative 1b. Questions on any of those? SOL A.4c-f was your system's word problem, so you had to define two variables, set up your two equations, and then after I set up the two equations, I used Desmos, change the variables to x and y, and put that into Desmos to figure out my answer. And then you had to remember which one was x, which one was y to answer, because they just needed one of the answers, not both. So 4 bottles of juice. Yeah, questions on that one? (28) and 29, you didn't really need to solve, but you could have still solved because it graphed the answer for you. So if you were solving, you should have gotten x equals 2, but what it did was took this part and graphed it, and this part and graphed it, and found that intersection. And then did the same thing for 29. You may have not solved it like this. If you solved it, I got rid of the fraction by multiplying everything by 2, so the answer was x equals negative. And we'll go to the last. Still need 28 or 29. This one. SOL A.4c-f was what we were just talking about last class. This first one is which ones are showing the subtraction property of inequality, so subtracting on both sides. So these first two on the left and then the one in the middle on the right were the 3. 2, it shows the steps to solve this inequality. It asks between which two steps was an error made. Between the first two steps, when they distributed, it should have been a negative, which messed up everything. This one you could have done on Desmos, and when you do this on Desmos, it'll shade it in for you. We haven't talked about that yet. We're going to be talking about how to actually graph it like that. when we come back from spring break, but you could have solved this like normal or used Desmos. So y is less than or equal to -6. It does say solve a graph on a number line, but I didn't, do that part because we haven't talked about how to graph it. On a number line would be, you would have to change them to y values, and it would have to be vertical. If it was x, you could have done it like a normal number line, though. Anyone still need this one? Or, I know we haven't talked about it, but still graph this to the best of your ability as it's shown. And we're going to be talking about this process. Really, you may have figured out if you did this one that the graphing piece is really the same process, solving it twice, and then the graphing is just a little bit different because we have to shade it. C we also have not talked about yet, but we will be doing that when we come back from break. Systems of inequalities, but you could have put these in Desmos and tried to figure it out. But B was your answer for 5. And C was your answer for 6. And then the one that will be due when the week you come back, so Friday we come back, will just be 5D, because it has a lot. So all of 5D will be going over the Friday of the week we come back. Again, you do not have to work on that over spring break, because we have that week when we come back, but if you feel inclined, you'll have it. And then if you don't already have out your compound inequality notes, take this out. Does anyone need another copy? And find this page. Last class we talked about or inequalities. Today we're going to talk about and inequalities. And basically it's the opposite of everything we talked about last time. So, and inequalities have a tendency to graph together. And we'll see what that means here in a second. So they give us some example. X is greater than or equal to -6, and x is less than or equal to -1. So the graphing piece, graph it how you normally would. So closed circle at -6, going to the right. Closed circle at 1, going to the left. Your and piece is where they overlap. So from -6 to 1. So when you go to draw this, you'll just need to draw the line in red. You can still draw the other ones, but I need to know that you know this is where they overlap. And the one in red is what we'll write our interval notation on. So this starts at -6. They're both equal to, so they're both going to be brackets. So it starts at -6 bracket, ends at 1, also bracket. before we continue, do you have any questions on that? We're going to be writing them. Matthew, did you have a question over each check? Do you have a question over each check? Okay. We're going to rewrite this in a specific way. So I'm going to rewrite this down here. X is greater than or equal to negative 6. And x is less than or equal to 1. We're going to write them as in a condensed form. That will look very much like how we wrote domain before. So start with negative 6, less than or equal to x, less than or equal to 1. So that part's not really new. So we're going to do a couple questions, and then if you have any questions that you want to see, do go over, and then move on to the next thing. So let's start with number 6. With OR inequalities, you solve those separately, do them separately. What you do to one, you do not do to the other. This is the opposite. What you do to one thing, you do to everything. So the goal is to get the x by itself. So we would get rid of the 4 by subtracting, and you're going to do that to all sides. So then your middle cancels, and then your numbers on the outside should change. Why is that like that? So then that would be our condensed answer. Negative 2 less than or equal to x is less than 5. And once you get the hang of this, you could just graph this part. You could still graph the overlap if you need to. So this would be closed at negative 2, open at 5, with the line that connects them in between. If you wanted to see the overlap, you kind of have to think about this as two separate things. The last part, by itself, x is less than 5. So open circle at 5, going to the left. You do not have to do this part, but if it helps you see it, feel free to do this. And then the other part, you have to kind of read this backwards. X, and then because this is facing away from it, that would be greater than or equal to negative 2. So then you could see that is indeed the overlap. For our interval notation, where would that start? Negative 2, parenthesis or bracket? Bracket, negative 2. Where does it end? 5, parenthesis or bracket? Parenthesis. Remember, sometimes you can have a mix, sometimes they're both parentheses, sometimes they're both brackets, it depends. Questions on any of that before we do another? We're going to do another down here. Let's do 9. 10 and 9 are like equal difficulty. Just not equal difficulty. So for 9, goal is the same. So we would get rid of the 1 first, subtract it to all sides. Rewrite. And then how would we get rid of the 2/3? Alex? Take the reciprocal, or flip it, is taking the reciprocal and multiply it to everything. So then this would become negative 3 is less than x 12 over 2. So 6. I'm going to put like a side note off to the side. You can write this if you want. If the 2 over 3 was negative, and you flipped it and multiplied it by negative 3 over 2 to everywhere, all of your signs would change direction because of the rule. So this would become positive 4 is greater than x is greater than or equal to negative 6. But anytime we write this, it has to be less than or equal to, it has to be least degree. So you would take the whole thing, flip it, if you have to divide by a negative. So that's something to keep in mind. But I just made that up if you happen to see a problem like that. Okay, so then graph this. Negative 3 open, 6 close, line in between. I'm not graphing the overlapping, but if you need to see that or want to do that, you can. And then how would we write the interval notation? Which word? Before we move on to the next thing, do you have questions on that or any other questions on this page you want to see? Do go over.
Okay, I did this last time, but I still don't understand how you tell which way.
So in this case, for your and, it doesn't matter. It's just going together. But if you were separating it, so like if I was reading this part, x is less than or equal to 6, pick some number. Is 7 bigger or less than 6? Bigger. So if this is less than 6 and 7 is bigger than that, I would not go that way. I would go the other way. So you have to like do that. Okay. Other questions? Cameron? Sure. There are 2 different ways you can go about doing this. One, because all of the numbers can be divided by 2, the 2, the negative 2, the 4, you could divide everything by 2 first. Or you could distribute and then solve. Your choice. Let's say we just distribute because that's what we're used to. Then is very much like our other problem. Add 12 to both sides. So this would be 10 is less than 2x is less than or equal to 16. Divide both sides by 2. 5 is less than x, which is less than or equal to 8. And graph that. Open at 5, closed at 8. Line between. Sometimes the line is really small, sometimes it's big, it depends. No problem. Parentheses at 5, bracket at 8. Once you have that down, if you don't have any other questions, go on to the next page. So what's nice about this last thing is that we already did solving absolute value equations, and we just finished talking about compound inequalities. This next piece is really just a mixture of those both. So let's talk about some examples, and then we'll do a few problems. I'll show you some kind of stuff, and then we'll be done for today. So for this example, anytime you see the absolute value, you're going to have 2 cases, as we had before, a positive and a negative version. this will be x is greater than or equal to 5. That will be one of them. And then we could graph that. Positive 5, sorry, close at 5, going to the right. Then you would take what's on the inside, keep that the same, change the direction of the sign so it's now less than, and make whatever this is negative. That would be your second case, and then you would graph that. So anytime after you've isolated your absolute value, when you go to graph it, greater than or equal to absolute value inequalities will be ORs, or inequalities. So that means they're going to graph apart. So that interval notation would start at negative infinity, go to negative 5, be a bracket, or start at 5, and go to infinity. Sometimes those numbers will be the same, sometimes they won't. It depends on the problem. But what is nice is, because it's absolute value, the sign will be the same. So like, if it's less than or equal to one way, it'll be greater than or equal to the other way. So they'll both be brackets. So they'll either both be brackets or both be parentheses. There won't really be a mix of the numbers. And then the other case would be the opposite. So one of this, the positive version would be x is less than or equal to 8. So I'm going to draw in all of these, but you can probably assume that this is going to be an and. And then the other would be the same inside, opposite direction sign, the number is negative. So that makes our less than or equal to and inequalities, where they overlap. So you don't have to memorize that less than or equal to are ands and the others are ors, but it may help you when you go to graph it. So then your interval notation would start at negative 8 and end at 8. Both will be brackets. And then once you have all of that done, I'm going to give you the definition and these steps. So absolute value inequalities are really compound inequalities, so that's good because we just did that. Less than and less than or equal to is and. Are and? Sure. Greater than or equal to are or. The steps for solving is really the same as solving absolute value equations. Isolate the absolute value expression, get it by itself. Create two cases, where in this case, when we create the two cases, we keep whatever it says the same for one case. And then for the second, we change the direction of the sign and change the sign value to a negative for the other. Solve both inequalities and graph. So then, of the examples we are going to do, I'll let you guys choose them. So we're either going to do 3 or 4, 7 or 8, 9 or 10. Starting on the first page. We're not doing 1 or 2 because we really just did that. So between 3 or 4, which would we rather? I heard 3. So we'll do that one. So we'll do that one. Okay. So the absolute value is already isolated, so we don't have to do that part. It is a greater than, so if you want to put like a side note that this is going to be an or. And then we can create our 2 cases. Keep one exactly the same as is, so drop your absolute value, x minus 1 is greater than 6. Then write it again, the inside x minus 1, change the direction of the sign, and make the 6 negative. And then solve both. Add 1 to both sides. So the order in which you do this part, graph it, rewrite it, write the interval notation is up to you. But let's say I graph it first, so both are going to be open circles, one at -5 going to the left, one at 7 going to the right. This is indeed an or, they're graphing apart. So I would write it as x is less than -5 or x is greater than 7. And my interval notation would start at -infinity, go to -5 with a parenthesis, or start at a 7 with a parenthesis to infinity. Before we do the next one, what questions do we have on that? Once you have this written down, go ahead and flip the page. And then between 7 and 8, which of those two would you like to see or do? 8. So when you go to like make your side note, right now this is less than, so it should be and. Say should be because if you end up dividing or multiplying by a negative and it changes the sign, it's going to change your type. So we have to isolate the absolute value first. How would we get rid of this -2? On both sides. So this becomes a +12. And I didn't change the sign. The sign should have changed. So what was an and is now an or. And then we can set up our 2 cases where one is exactly the same. 4x minus 8 is greater than or equal to 12. And 4x minus 8 is less than or equal to -12. And solve both. Add 8 to both sides. We have 4x is greater than or equal to 20, and 4x is less than or equal to -4. Divide 4 on both sides. So x is greater than or equal to 5, and x is less than or equal to negative 1. So our OR should be x is less than or equal to negative 1, or x is greater than or equal to 5. Close circles for both, going in opposite directions. And then our interval notation would start at negative infinity, go to negative 1, bracket, or bracket 5, infinity. Questions on that one? And then between 9 and 10, which of those two do you want to see, please? 10. Okay. So we need to isolate the absolute value first. What would be our first step? How do we get rid of the 1/2 and the 11 that's around here? Okay. Get rid of that by subtracting 11 to both sides. And then get rid of the 1/2. So you could divide by 1/2 or multiply by 2, either or. I'm going to multiply by 2, but if you divide by 1/2, that would also be the same. I didn't do this at the beginning, but this is a less than, so that should be and. As we've isolated it, the sign has not changed, so it's going to say an and. So now we can rewrite this as 1. So 4x minus 4 is less than or equal to 8. Rewrite the other. 4x minus 4 is greater than or equal to negative 8. And then solve both. Add 4 to both sides. Divide both sides by 4. So then when we write this as a condensed format, it's going to be greater than or equal to negative 1, less than or equal to 3, so it's going to be between those two. And your line would be between those two points. With brackets for both numbers. Do we have any questions on that? Any other problems we want to see or do before I show you these compound mean problems? have a blank page after your next additional practice in your notes. So write these there. And I'm going to rewrite them also. Negative 8x plus 44 is greater than or equal to 60. Make sure you know it's an and then negative 4x plus 50 is less than 50. Make sure you have both of those written down. So we're going to solve both of them. They don't write the and ones together, but you're going to solve them just like you normally would. So I'm going to focus on this one first. Get rid of the 44 by subtracting. What is that, 16? Someone double check that. And then divide both sides by negative 8. This sign is going to change directions. And then do the other. Subtract 50. So negative 4x is less than 8. And divide on both sides, and your sign is going to change again. Sometimes your answers will be straightforward. It will look just like what we did in class. Sometimes it'll be different, as sometimes it is. Your and works the same way. You're looking for where do they overlap. Drawing number lines will be your friend with these. So the first one was x is less than or equal to negative 2. So this is negative 2, it's closed, everything less than it. And then the other one is open circle at negative 2, going to the right. Where do these overlap? At negative 2, that's it. So, you can't see the answer, but it's less than or equal to negative 2, equals to, greater than negative 2, no solution, all values. This was one that some of these are weird. So they do overlap at negative 2, but I think because they don't want just one value. Because it's inequalities, there has to be a lot of values, or at least more than one. That's why there's no solutions. I'll look into that one. But that one is a weird one. But sometimes they won't even overlap at all. So it'll be graphed like a or, and then they wouldn't overlap. Sometimes they'll overlap everywhere, and then it would be all solutions. So just be on the lookout for that. Okay. And then or. 5x minus 19 is less than or equal to 1, or negative 4x plus 3 is less than negative 6. and then solve both of these. So add 19. Divide both sides by 5. And then for the other, subtract 3. Divide both sides by -4. The sign is going to change directions. So I think this would be a true or, like what we did in class. Sometimes it's looking for everything, so not where they overlap per se, but reading it left to right. How would I write this? And that's what it wants sometimes. So sometimes they overlap and it just wants like, okay, if I read this left to right, how would you write that? But this one's going to be, oh, 9/4 is in, got it. What is 9/4 as a decimal? So it's less than or equal to 4 and greater than 2.25. So if it keeps reading it left to right, it starts at -infinity. Even though it starts here for this one, it was already started for this one. And then by the time this one ended, it already kept going. So the solution for this one would be everything. So read it left to right for your ors. But for ands, it's still where it overlaps. Okay, questions on that? So for the remainder of class, you can be working on Khan Academy, SOL, whatever. If you have other schoolwork or want to be on your phone, any of that you can be working on. Let me know if you need my help with anything, have questions.